Hi everyone, I'm going to show you guys how to integrate sine inverse x into cos inverse x. So this basically means arc sine x into arc cos x, right? So you guys know this. So what I'm going to use to solve this question is I'm going to use integration by parts. So this is the formula for integration by parts. So you use integration by parts, so you have to take one term as u and the other term as dv over dx. So it's like this. So in this case, we know what the differentiation for sine inverse x and cos inverse x is, right? But we don't know what the integration is for sine inverse x and cos inverse x. Separately, we don't know the integration, right? So anyways, what I'd say is it doesn't matter which term you take to integrate and which term you take to differentiate. So you could take cos inverse x as u, and you could take dv over dx as sine inverse x. You could do it like that, any way you like. So I'm gonna do this. I'm gonna take u equals to cos inverse x, and I'm gonna write dv over dx equals sine inverse x. Okay, so du over dx equals, the differentiation of cos inverse x is minus 1 over root 1 minus x squared. That's easy. You guys can remember it. It's well, if you guys want me to show this, I could do it separately if you guys have any doubts with that. But this basically you guys can remember, because these are like the basics of trigonometry. You basically have to remember these. You don't have to show it every single time in every question. You could just straight away write the answer like that. And the integration, so dv over dx equals to sine inverse x. So in this case, we need to find v, right? Meaning we have to integrate sine inverse x to find v. So let's do that first. So you write v equals the integration of sine inverse x dot dx. Okay, so now just forget the question for now and focus on this. So you can see when integrating sine inverse x, you'll have to take one term as u and the other term as dv over dx, the same way, integration by parts. So I'm going to write sine inverse x into 1 dot dx. And I'm going to take u equals sine inverse x, because we know the differentiation of sine inverse x. We don't know the integration. And I'm going to take dv over dx as 1. Wait a minute. So I'll take it as v dash dv dash, because we have v over here. Since you guys have to do integration by parts twice, you guys might get confused, right? So I'll take this as u dash and v dash. So that's better. So now you can write du dash over dx equals to, so the differentiation of sine inverse x is 1 over root 1 minus x squared, and the integration of 1 is x, right? So v dash equals x. So if you go back to your formula, so in this case we have u dash and v dash, remember that. So u dash into v dash minus v dash into du dash dx dot dx is your formula for this question. It's just the dash, alright? So we have x into sine inverse x minus the integration of v dash, which is x, into du dash over dx, which is 1 over root 1 minus x squared dot dx. So you can see now what we have to focus on is this, right? So let's integrate that. So x over root 1 minus x squared dot dx. This is easy. How do you integrate this? Let me take a substitution of t equals x squared. So if t equals x squared, we have dt over dx equals 2x, right? So dt over 2x equals dx. So you go to your question, you have x over root 1 minus x squared dot dx. Instead of dx, you write dt over 2x, x cancels off. So now we have to integrate half into 1 over root 1 minus t, right? Dot dt. So how do you integrate this? This is easy. We can write it as 1 minus t to the power minus half. So how do you integrate that? It's minus half plus 1 over minus half plus 1 into 1 over the coefficient of t. So it's minus 1 into half, because you got the half over there, right? Ignore the c for now because we have so much more to do, so you don't have to add the c for now because we are only finding the integration of sine inverse. Okay, so now you can see these so it's going to be minus, you'll have this becomes half, so it becomes 2 into 1 minus t to the power half into half, right? So these two cancel off, and if you put your substitution back in, it's minus 1 minus x squared to the power half, because t equals x squared was the substitution. So if you go back to your question, so now we are finding the integration. We are finding v, which is the integration of sine inverse x, which we get as x sine inverse x minus, see we had a minus in front, we only took this part, we didn't add the minus for this integration, so we'll have to put minus 1 minus x squared to the power half, right? So our answer is x sine inverse x plus root 1 minus x squared. So this is the integration of sine inverse x. Okay, so if you go back to your question, I'll write it with another color. So our question was this, right? Integration of sine inverse x cos inverse x. Yeah. So we took u equals cos inverse x and dv over dx equals sine inverse x, right? So we wrote du over dx equals 1 over root 1 minus x squared. There's a minus in front of 1. And to find v, in this case, now we found it, v equals x sine inverse x plus root 1 minus x squared. Yeah, now let's go use our formula. So this is the original formula for integration by parts. So u into v. So u into v is x sine inverse x plus root 1 minus x squared into cos inverse x minus the integration of v. So I'm going to go on to the next page. V into du over dx. So x sine inverse x plus root 1 minus x squared into minus 1 over root 1 minus x squared dot dx, right? So we have a minus, so this minus and this minus will make it plus, right? So we'll leave this part aside for now. Let me write with another color. So if you multiply, you'll have the integration. You'll have plus in front because minus and minus gives you plus. Now you have x sine inverse x over root 1 minus x squared plus. So if you multiply these two together, you can see they cancel off, right? Plus 1 dot dx. So the integration of 1 is x, right? So you can write x plus the integration of x sine inverse x over root 1 minus x squared dot dx. Now guess what? We'll have to use integration by parts again to solve this. And this is your last part. You don't have to use it again. So after doing this, we get the final answer. So how do you do that now? So now let's take the same way. Let's take u equals sine inverse x. Let's take dv over dx equals to x over root 1 minus x squared. So du over dx equals to 1 over root 1 minus x squared, right? And the integration for this to find v, we found it previously, right? V equals to, we found that earlier. So the integration for that was minus root 1 minus x squared, right? So you use your formula again. I'll write the formula again so that you guys don't have to pause the video and go all the way back. So this is the formula. So now it's sine inverse x into minus, so that's minus root 1 minus x squared minus v, which is minus root 1 minus x squared into du over dx, which is 1 over root 1 minus x squared dot dx. So you can see these two will cancel off and you get plus 1. So you have minus sine inverse x root 1 minus x squared plus the integration of 1, which is x, plus c. Yeah, now we'll have to put all our answers together. So let's go to our previous section, which is this, which I've underlined in black. So it's that, and since I told you guys previously, this minus and this minus, since they're all multiplication, becomes plus, right? So it's the section I wrote that I underlined in black. So the final answer is x sine inverse x plus root 1 minus x squared into cos inverse x plus this, right? Plus the integration of this, which we found later on. So we had x plus x plus the integration of this part, which we just did previously. And the integration for this we found minus sine inverse x root 1 minus x squared plus x plus c, right? So your final answer, we could simplify this further, right? We could just expand the brackets. So we have x sine inverse x cos inverse x plus cos inverse x root 1 minus x squared minus sine inverse x root 1 minus x squared plus 2x plus c. This is your final answer. It's a long answer, right? Yeah. Let me just circle it with another color. This is your final answer. So if you guys have any doubts with this question, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Thank you so much. Have a great day.